Welcome to welcome to a presentation on logging in a DevOps world. One right away. Everything shown in there is part of the Q framework module. It's a part of scripting framework that MIT and this whole developer provides tools to allow you to deploy code faster. That's the main point. Main takeaway right away, which is why I thought that's the first element. I've got a no break and change contract on this. This means that whatever I do, I can't introduce a break and change after the fact, which is part of the reason I have to live with a few suboptimal decisions, covering a few of those. On the plus side, you can rely that what you build with this will still work in a year. Okay. I'm Fred. Some people call me Friedrich Weinmann. Unless you're out of the Nordic or Germanic culture group, I'd appreciate if you could just call me Fred. I'm a former Microsoft MVP for cloud and data center management, and since September I joined Microsoft as a premier field engineer, which is a bit ironic because I had to return my MVP title almost before I got it. As a Microsoft employee, you can't be a Microsoft MVP. That's a community title. And I signed my contract with Microsoft before I got the notification on the MVP title. So I already knew the day I opened the letter as, oh, right, great. We were fast about that. But I still got my stuff. You can find me usually on the PowerShell Slack or on Twitter, but I'm not that active on Twitter, I have to admit. One of the main projects I work with is the DBA Growth module, which is all about SQL Server management. So using Microsoft SQL Server management, and everyone they're ever angry with Microsoft that the SQL Server module isn't really up to the task. Try to be able to. We've got you covered. All right. Now, in the entire PowerShell ecosystem, there is what I consider the bastard child. There is one command that has taught the entire PowerShell world one of the worst practices I've ever encountered. And the thing is, everybody thinks that's the state it should be. I mean, really. Anybody want to guess what the command could be? It's a PowerShell default since version 1. It's not a public killer, it's not right host, it is in fact right levels. Now, why the hell would I have anything against right levels? Right levels is awesome in that it has opt-in messages. So somebody who wants to know what is happening right now can put on this trigger and tell, give me what's currently going on, but the regular user is not flooded with messages that he might actually even care about some a command that is doing the job it should be doing. I'm afraid I'll have to go a bit in history for this one. Once upon a time, there was junior admin Fred, who was, for a customer, doing a script. Testing it a bit out. I already had learned that from Germans that right host puts puppies, and I like puppies, so no, we're not going to do that. I also learned from painful personal experimentation that right output is not an alternative, because it poisons my output stream with strings when I actually want objects. So I was using right verbal. Okay, fine, ran the script, boom, error. Okay, ran the script again, this time with dash verbals, and well, wall of red still erroring. So I was doing some debugging, getting some progress, figured out what was happening there. At some point, I got a call. Yes, Fred here? Hey, here's a customer. Why are you currently constantly rebooting my terminal server? Well, we did agree on that downtime. Remember, I'm still debugging the script. Well, it was one reboot. Sorry, one second. What's the main bad practice here? The main bad habit? With dash verbals in use for debugging, rather than I want to know a bit more about what exactly is happening right now. The logic is our code breaks something. So now we have to run it again and break it again in order to start figuring out what's happening here. If it's about let's search Active Directory for users, this is not so much a problem. We can do that again and again, no problem. If it's however, it might perform a change. Next thing, after it failed the first time, we're currently in an unknown state. So there is literally no guarantee that the next time we run it with -verbose, it's going to encounter exactly the same thing. Happened to me in that case. The second time I tried this, the terminal itself was rebooting, so I could not connect. It was still a wall of red. I was at the state where a wall of red was all I really read when I got a wall of red. I did not probably all messages yet at that point. So it happened. I spent hours on debugging on this, and rebooted the server a few more times than I was agreed upon, because I was using it for debugging and I did not have any forensics, any information that would give me a lead to this. How could I handle this? And that is the main reason why I really dislike DevOps. It's nice for opt-in messages, but it's not a debugging when it's used as that. So, let's take a look. If not couple is this, oh, which of course it does not. Now the first thing is there's the one golden command you really have to remember. Once I've got it to a slice, you can actually see what's happening here. Write piece of message replaces write verbose. It also replaces a few other things we'll be getting into that soon enough. And as you can see, nothing was shown because we did not specify the verbose parameter. With the verbose parameter, we get a verbose message as we'd be used to it. With a bit more information, which I find convenient, you can disable that if you want to. You're not tied, you're not forced to have that extra debugging information. That's optional. It's just enabled by default. The main thing here now is there's a command called getPSFMessage that will retrieve all message, even the very first one that we did not actually had the -verbose parameter on. So what this allows us is at any time retrieve all the messages written, even those we were not shown for whatever reason, out of the memory. It's stored on a static list. There's a maximum capacity for that. You can configure that maximum. It's just so you don't run out of memory if you log expensive logging information. But you can configure that to your own preference. Okay. Now let's try running the same thing again, but this time there's a new parameter called level, because write PSF message covers multiple logging levels, multiple scenarios. The verbose obviously is writing to verbose, but we can also run a default message to host, replacing write host, and still have the same logging capability. Any question? No, it's a part of the PS framework. Which is why I gave that disclaimer right away. We're going to need that framework if you're going to be using this. It's compatible PowerShell version 3 upwards, including PowerShell 6.1. So it's as compatible as I was able to make it. We can also write warning, which will be shown as usual. We also have write debug covered with this, which then if the debug parameters toggle has the same behavior as the default write debug does it. Well, let's find it out. Now, there's one thing a friend has always said about me. There is no technical solution that Fred cannot over-engineer. Especially when the playing kid Fred is getting his hands on some code, including HTML-style color tags, which you can embed into the text, which will not show up in the logs, by the way. We can run getPSFMessage again, and as you can see, there is no color tags involved here in the logs. It's just for display to host. Well, let's take a look. We've got a command, a function, that just writes a few verbose and debug messages. That's fine. And there is one special parameter in write_PSFMessage called -breakpoint. And what that really does is it changes the behavior of write debug. In the default write debug, if you've got a large command selection and you specify -debug, it will enter a breakpoint on every single write debug. The PowerShell framework only does that when you specify the -breakpoint parameter. or if you call it directly behind right piece of message. So when we run it without any parameter, nothing is shown. If we specify with verbose, only the first message is verbose. And if you specify it with debug, only the last message was specifying an interrupt prompt. Important other feature, the debug message has another property shown by default. That is the line number. This is in order to help you set breakpoints if you want to actually run through the same code again with the debugger. So you can specify exactly which line to set the breakpoint on. Which is the key message I really miss out of the default by debug text display. Thank you very much for helping me setting a breakpoint where I actually need it. So, now, this is all nice. I mean, we're talking about in-memory logs. That's cool, but nobody of you heard, hey, I want to log something in memory when you went to a logging presentation. So, there are the logs. Now, problem. We only have 3/4 of an hour. I can't cover the entire complexity of the configuration system. That is to say, there is a configurable path where the default logs are written, which is stored under this name. You can deploy the setting with script code. You can deploy it from registry via desired state configuration, JSON configuration file, web link. Whatever is your specific use case in this. So, let's take a look at the actual log files. Oh, thank you. Yes, I want F8. Okay, there is under app data for the current user folder that will be automatically created. That is the default debug log that the PowerShell framework will write. It contains logs up to 7 days into the past on the default settings. So it automatically log rotates everything. And this allows you to, for example, set up a scheduled task with logging enabled without having to care about the logs, but with be able to look up after the fact what has actually happened in there. So this one would be from the current session. So let's drag that into VS Code. And it is a fairly large file. You might recognize some of the messages from here. It has timestamp, computer name, username, file that was written it, and what line it was written, what command wrote it, in what module was the command from that wrote it. So, and extra pieces of information. So you get rich debugging information out of the box without having to really care about this. So if you want simple logging, all you really need to do is replace your write verbose or write warning or write whatever with write piece of message and go home. That's it. That's all you need to do. So let's try something else. The error record parameter allows you to also log exceptions. This is the replacement for write warning. You can enable the usual message of red that's written to the screen. By default, it writes only a warning. And it allows you to also add the complete error object into the logs. Let's see how that looks. First of all, I wonder why this would fail, but let's see. The first thing, it immediately added the exception message to the message written. Unless you disable it, you can disable that if you want. But it means you don't always have to please add this line, please add this error message to the message you want to write, whatever writing solution it handles that. And we have here an XML file, which we can now import with import CLI XML and debug as if we had called the error object in memory. All the information the object would usually have. It is also subject to the time-based lock rotate. It is also subject to the size-based lock rotate if it has an upper limit of 100 megabytes per user account. Just to be sure now that you dump everything on the system and actually flood a low-sized machine, so it covers that as well. And this includes the default debug logging that's enabled by default. Now, you can also use this for tracking information. I've built an example function that writes in the begin block, just, hey, I'm beginning. And then it uses the target parameter to log what object it was currently processing. Imagine you're gathering information from 500 servers. What server are you actually processing? You can write it in a message, but that's hard to evaluate. If the target property, you can after the fact search by track progress by the object that was processed. So let's run the numbers 1 through 3 to that. And if we now get PSF message target 2, we get all messages relating to the second item that went through the pipeline. We don't have the begin messages, we don't have the end messages. We have only the begin for object 2. Another thing, you can tag messages. You can give them tags you can apply rules and filters to. This, of course, includes the get PSF message being able to search by this. The tags also end up in the logs. So we can grab all start messages. I generally recommend special kinds of operation, whatever you organizationally need. There is no out-of-the-box logic behind tags. You can apply rules based on the tag, but there is no default list of these are the legal tags. Any kind of text is viable. So, at this point, somebody might wonder, now we've got a nice logging solution going here. It's cool. It makes my life easier, it's workable, but the session title was about DevOps. Like logging in a DevOps world. What part of that is particularly DevOps? I mean, logging, don't be confused about that. DevOps. So, what would you associate with DevOps really? The first thing is what Jeffrey Snow already said as one of the first items in his keynote, and the last two keynotes, automation. If you can't automate it, it's pointless. This is a lot where the configuration system comes in. We'll be covering that a bit more, but not too much. It needs to be scalable. 1 machine, 100 machines, 100,000 machines, 1 time, 5 times, 100 times. It needs to cover any scale at any kind of flexibility. The logging itself must be cheap. If we have performance degradation in our service because we write a log, that's a problem. Think about the message you just wrote to the file. In traditional write log commands, well, you've got a disk I/O for every write operation, yeah? And that's slow compared to in-memory operations. So the regular default write log commands everybody has probably written in this PowerShell live, they are always slow on the code. If you have a script with 5 messages, that's not a problem. If you've got a script that writes 5 messages per computer and it targets 50,000 computers, you start feeling the impact. That needs to be adaptable. Depending on the scenario, it must change. DevOps is a fast-moving world. If it can't easily adapt to the changes that's happening to it, it's a problem. A real problem. And that comes in 2 flavors. On the one part, being changeable within the technological context that it currently is. But even if you completely change your technological platform, the migration effort to move your logging to the new platform must be easy and without any loss of information. You can't lose like half a day of logs just because your migration is stalled out or you had an unexpected error you had to address. You're in an unknown state at that point. You can't do that. So, automation and adaptable is handled through the configuration system. Every single part of the logging aspects can be deployed by configuration. And you can use the tool, whatever tool you really need in your scenario. So As an admin, you could have a group policy that says, hey, I've got a central logging server, set all my logs over there. That's cool. Now you've got a few scripts, and you've got another team that is running development automation for another department. They could use a script, but under the usual paradigm that's going on right now, they'd have to rewrite the entire logging. They'd have to change your script. You can't use your script and apply another configuration. With the PowerShell framework system, a few of the elements you'll be getting in, they can take your script, not change a single line, get your updates without having to reapply anything they changed, and use your script in their logging scheme without any impact. Scalable and low impact. Logging has, where scale is concerned, a major benefit, that the real thing that has to scale is the data manager, the one that is receiving the logs. The log writer, the one that's providing the data, does not have as much problem on scaling on number of servers it's running from. If you're running it on 500,000 servers, no problem, just the logging destination can handle that, which is nice. The other thing, however, is what if your code has to scale on performance? When you have like a script that is running on a large server machine, 500 run spaces in parallel, doing network calls and waiting. It's a reasonable size, by the way. You can run 500 run spaces completely parallel if you have network waits in there. But under regular usability scenarios, you've got write conflicts as soon as you try to write to the same 500 from multiple run spaces. Solution of the PowerShell framework is you've got a central logging run space that is running in the background and performs the actual logging. So it's guaranteed that you will never have a write conflict, only one run space logging. And at the same time, this is also the part that removes the write impact from the logging command the script executes, because all the script, the write piece of message does, is queue a message for the logging. It does not actually do the write to file, write to network service, so you never have to wait for the logging to complete for your code to continue. And the migratable part is the logging system is actually plugin based. You can add easily another plugin that logs to message queue or to Azure Logging Service or AWS or whatever your actual logging need is. And using configuration, you can tell all your scripts now use this logging provider without ever having to touch a single script file. And this is another main part, you can operate several plugins at the same time. What this means is you can have a soft cut over to your new logging solution in production, tested with production material, without losing your previous logging system. You can have like 1 month or 2 months coexistence phase to be sure everything works before you actually cut off the old system. And you couldn't do that in phase steps, so you don't. You can see that even the cutting all of the logs does not hurt anything. And going back a little bit on scale, the run space safe aspect also applies to the messages as you see in memory. Now, this is the full message object that is written to that is stored in memory. It includes the message, the type, which we will not be getting into for this event. It's thank you. PowerPoint on full screen. All right. We've got the message. We've got the type. We've got the timestamp, the command that wrote it, the module the command came from, which in this case is unknown because it was in memory defined, the text you specified, if any, the level you wrote at, and this is the fun part, the run space ID. Which means this suddenly allows you to, at runtime, look at what's happening in other run spaces. You can just start a run space job and let's search for what messages that specific run space offered. Computer name, target object if you specified any, the file that actually executed it, the line it was run in, and this is one thing I really miss from default information, the call stack, at the time it was written. So that's that. Let's start us some run spaces. What this uses for the demo is push out job from both procs. It's basically start job, only doesn't start a new process, it starts a new run space. Otherwise, it handles exactly like the default job commandlet. So what we're doing is we are running 5 jobs that each will write 10 messages, but with a random delay built in, so we have no idea about the order. They're running. And now we can just sit back and look at what's happening in the background run space. Okay, nice. All right. Now I talked about you can add your own logging provider. You can add your own logging plugin and just piece it into the logging system and it will run with that. Let's take a look at that. Out of the box, there are 2 logging providers actually. Only one is disabled by default. We've got the file system provider. I'd love to be able to rename that one. That would be a breaking change. I'd like to call it the debug log by now. But at the time, as I devised the whole thing, it was the only logging provider. And I call it the file system, and anybody that has a policy that controls the file system would otherwise be affected. So I can't do that. Logging providers can be disabled, they can be enabled. They initialized means that the logging system actually picked them up already and was probably able to retrieve them. So there's another one, the log file. This is the provider that's designed for, I've got a script, one script, and I want that script to write logs for me. I want logs only for that script. When I look at the debug log, I've got like, I could have logs from hundreds of different scripts in the same folder. That's not neat. I want something that looks exactly the way I want it to. And is exactly for that one process, for that one logical operation that I actually want to perform. A friend of mine pointed out that it would be kind of nice if that was available out of the box, because the logging plugins are a bit complex for him and he is scared of what I wrote as a template. So, all right, we can do that. So what we have is the command zpsf logging provider that configures already existing providers. I'm using splitting because that's kind of neater. So we target the log file provider. It wants a path that log to. Then the file type you want to log as. You can have CSV, XML, HTML, or JSON. And I tell it, yeah, I want this provider enabled. Let's enable that. And just to be sure, everything I'm running with zpsf logging provider could have been done by configuration. I just did it as an interactive command because applying configurations at runtime is a pain for the logging system. That's basically designed to be already configured before the script starts running, or the editor. So, all right, the provider is enabled. Should be, better be. Yes, it's enabled. Write some messages. And let's take a look at the actual file. All right, now we've got a JSON file with log events, with all the information that was part of the message object. Easy at hand. It complains about syntax error here. Anybody know why? Exactly. A list in JSON requires an opening and closing bracket, and it doesn't have one. Why? Because the system can never know when the last message was written. So I can never really apply a closing bracket. So I decided, okay, if I can't do that, all right, I also won't do an opening one, and you can just, when you try to parse that, read it into and add it manually with concat, because you have to call concat anyway. to add the second one. Okay, let's save to disable that before I completely spam that file. Any questions to that point?
If I want to extend it to a remote syslog, is it possible?
To what?
A remote syslog.
Sure. I literally implemented SQL Server as a logging destination. I implemented for RabbitMQ. I implemented one, with assistance, I'll admit, to AWS CloudWatch. All of these were customer specific with customer IP, so I could not implement it as part of the PowerShell module. Also, I must admit, I am hesitant about adding additional provider out of the box, because anything I put in there is solid. I can no longer change that. So I really only add another logging provider if I'm sure I can handle the quality I am still confident I can live with in a year or two. There might be some exceptions about cloud services, because the logging provider would have to change to the service it's logging to, of course. But outside of that, I really am careful about adding additional logging providers in that regard. In that case, let's go to the terrible complexity of defining a new logging provider. I'll be starting a new PowerShell console for that, and we will probably need a slightly larger font size. Thank you very much. Okay, what we're creating is an event log logging provider. All it really does is it calls write event log on the message that was written, which is why it's assigned to the message event, a script log. Oh, wait a sec. Sorry, now I got slightly confused about my order, because I really should be covering the details first. It's event-based, so you assign script logs to specific events within the logging process. And that's the one part you have to take care of if you implement your own. Since the individual script logs need to pass information to each other, everything is running in the same scope. So if you have a naming conflict with the variable from a separate logging provider, you could be screwing with yourself at that point. Unpredictable event. I usually just say prefix the variable name with the logging provider name, but it can only be one logging provider with a specific name. All right, and this is the logic as it happens. When the logging system picks up a new logging provider, whether that's on import of the PowerShell framework module, or after the fact, when a new logging provider was enabled, it first tries to run a script log that is executed a single time. This is where you can store one-time information. This is where you can define helper functions you want to use later on. And then it doesn't have virtually permanent cycle of a very small way to avoid maxing out the CPU. It will have a start event. It will process the messages. Then it will process the error objects. This is where the XML came from, the logging folder. And has an end event, which you can use to optimize message sending in order, for example, on metered system, avoiding sending an individual message per logging message, and rather bulk them up and write them in bulk. Which, for example, with AWS CloudWatch was like an average of 60% saving. And is the reason we have that event. And at the final event, when everything ends, a finally will execute. Final event, what does that actually mean? When the PowerShell process ends, it will wait, flush all the logs for a configurable timeout, and will trigger the logging run space. Sorry guys, we've got a termination signal. At that point, it will enter a finally block and try to finish that. If you've got a terminating error that would force your PowerShell engine to close, it will still do that. Problem. If you've got an instant crash this process error, like if you've got a .NET corruption or things like that, finally is not executed, and you might actually lose logs, last two messages. You've got up to 100 milliseconds wait between each cycle, so that's almost the maximum time duration you can lose in logs. This is the cost we pay for having asynchronous logging in order to not have it impact performance. Since most of PowerShell doesn't really have a problem with that, because we rarely really completely crash the entire process. This is a price I was willing to pay in order to avoid having that I/O cost. Like originally, when I devised the entire system, I didn't even know where I was going to take this. But that's the one thing to keep in mind. If you've got a host that does not properly end PowerShell, example, PowerShell agent in SQL Server does not properly send a signal to the PowerShell engine because it has a custom host implementation. At that point, the background run space that is doing the logging will hang the task. Like totally hang the task. The job will never finish. For that, there's a command called wait piece of message that ensures all the messages are ended, and then will cut down the logging provider run space. So at that point, you can force shut it down without having to actually work around the system. So this message event, this logging provider simply writes event log message without anything special. It just takes the entire message object, uses format list on it, and outstrings it exactly the way it would have been displayed on the console and puts that as the message text in the message. And we have an event ID 100 with the message in the event log. That's all we need to have event log logging for PowerShell. Okay, we need a new console. RSS restart shell. Just restart the PowerShell console. Okay, now we had this nice error XML, and currently we have no error event, so all the exception code is gonna be lost on us. Now, I don't like losing that meta information, and in the Windows event log we've got an error event type, so let's implement just that. The message event is unchanged, but now we have an error event. It takes an exception. And what I do here is, first of all, a proper ID, a proper entry type, and use convert to PSF CLI XML. That is almost the same thing as export CLI XML. However, one, it uses compression. So it actually does not completely flood your event log size because default export CLI XML and reading this string would do that. Second, it does not need a file. It does the conversion in memory. So you don't have to have a file ready for that somewhere, which would be a weak point that might break things. So registering the provider. And default error log. And if you look at things now we've got an error message in memory. Yeah, and I immediately know what this means. Okay, now we need a little more tooling for this, and we can use that with PowerShell, since we're already into automation. We can just search the Windows PowerShell for event log ID 666. I'm assuming only my own commands are in there. We could be a bit more specific about the filter. And we can use convert from PSF CLI XML on the message object to reconvert it into PowerShell error object. Thank you very much. Here's code. And at that point, we have, again, the error object with all the meta information to search, to troubleshoot, to debug. Okay. Finally, we can, of course, also handle the warnings while we're at it, which basically just checks whether the message level was a warning. At that point, we differentiate, and at the end, we get the right event, right event on that. It's exactly the same as we did just now, no changes. So I'll be setting us that one. Final thing before I am pretty much on time as I originally intended. Not this one. This is an example full stack provider. I wrote one for PSS SQLite. Just for demo purposes at this point, we have a registration event. This is logic that is executed the moment register PSF logging provider is executed. This allows you to contain the entire provider information, including needed logic, as part of one data object and import it. That's been used for one point, which is where that event comes from. The begin event, which I really regret naming begin event, I just can't change it anymore because I really should have switched begin and start. That the start is the one that is only executed one, and begin is everything. Just so we have begin, process, and like we have in PowerShell. It would have been more intuitive. It was a lapse of judgment that has been haunting me now for more than 1 year of cursing myself for that naming. Okay, in the start event, we look for the data source. That is the SQLite file we using as database. The message event simply inserts timestamp and message. We ignore errors because proof of concept will let me more. We don't have any ending event at that point. Final event, we don't need any final cleanup on this since SQLite is fairly painless where that is concerned. Now at that point, this is a nice provider. All the events we had so far, but we don't have configurability right now. We don't have, wait a sec, the system does not have the prerequisite PSSQLite module installed. We don't, only with this configuration data, it's not yet ready. Providers have a state that's called, they need to be able to check are all prerequisites there, and they need to be able to install these prerequisites if configured to do so. So we have configuration parameters and configuration script that dynamically generate additional parameters for a set PSF logging provider. They create dynamic parameters so you can provide provider-specific information. Like, for example, with the script file provider, that it actually needed, which file type. The SQLite logging provider will have no use for that parameter. And I can't provide for all parameters, so you can provide dynamic parameters. However you want to generate them. You can use your own logic. The default template includes using parsing the configuration system for the configuration settings you define in the configuration system. So you don't need to change anything there if you're using the default configuration system, which is the supported and recommended way to go about. A script block that tests whether all prerequisites are available, which in this case is the module PSSQLite installed. You can, for the install command, offer specific parameters. Again, I recommend using the configuration system for that. Doesn't need one in this. And the install script is the logic that is executed to install the prerequisites, in this case, install module PSSQLite. If that fails, it cannot report the provider as installed, it cannot initialize it, it cannot use it. There will be log messages included that this failed. And finally, defining the configuration system, which in this case is the log file for the SQLite database. It assumes at the moment, because it's simple proof of concept, that the correct database table is already available. You could make that part of installation, and installation is installed script logs. Okay, this is the full script logic that's available. I'm going to run very fast through the remaining few slides, because now that we have the logging provider, how can we best handle that, manage that? There's basically three solutions. One, you can just plain deploy the PowerShell framework, and in your deployment, as you have it in your internal gallery server, just add the script files to the other logging providers in the same folder. It will be used, logging provider will be available. That's the least effort you can do. It works that way. It has exactly zero code impact. Problem is, on all updates for the PS framework, you have to go back and re-inject your custom providers. And yeah, only system-wide settings. I forgot. One master configuration with a master configuration file. Where you load, oh yes, now I remember, system-wide, you only have like global policies. It does not include any specific, I can import from this configuration file. You can only use the global deployment options. Like in HKLM, there's a specification if you look for configuration. There's a specific folder if you'll be looking for JSON files for configuration. This allows you to use the same thing on Linux systems. Yes, it works completely on Linux. In the master configuration, you basically tell all your scripts, get your configuration from, let's say, this server or from that where, but it requires infrastructure that must be available at runtime, and it's not quite flexible to manage. But it's still easy to implement in the script that's using this. We're almost done. Last slide.
The other session has started.
Yes, you're literally on the last slide.
Sorry?
You're literally on the last slide. My recommendation is build your own module that depends on the PS framework, and that gives you the best of all worlds. It takes a bit more initial implementation effort because you have to define a module. Yes, my project has a solution for making that less effort, but that way you can avoid any code impact and still have targeted configuration and targeted logic that you can deploy in your own module. You also do not need to inject the logging provider into the PS framework because you can have that in your own module. That's the most manageable and scalable solution if you want to deploy this to large scalable platforms. Please do this. All right, thank you. There are additional resources. I will be publishing it on my GitHub. The entire presentation materials, demos, everything. If you've got any questions, please contact me. I'll be happy to answer any questions you might have.